Alright, so here's a quick lesson on geometric sequences. So we're going to start out by defining a geometric sequence as having a starting value and a common ratio. Okay, and in this geometric sequence, the starting value is defined by the variable a. So we have that variable a. And then the common ratio is defined by the variable r. So we're going to have that variable r there. Alright, and you see in each one, we're multiplying that particular r by the a. Okay, we've got two different ways we're going to do this with recursive and explicit. Alright, and we can see the recursive definition is here. We have a starting value of a1. That's your start value, your initial value. Okay, and then the formula is given by this formula here. We have a sub n is equal to a sub n minus 1 times r. So we're going to take the previous number and multiply it by r. Okay. All right. Then we've got what we call an explicit definition, and the explicit definition lets us find any particular value at any particular given time. So even though we may be only given 3 numbers, we could actually find the 10th number as long as we know the starting value and the common ratio. All right, let's take a look at the first couple. And in the first couple, we're just going to try and look at identifying whether or not something is a geometric sequence. All right? So we're going to ask ourselves this question. Is there a common number we multiply by to get the next term? Okay. So that's what we're going to ask ourselves to determine whether or not it's geometric. All right? Is there a number that we can multiply each number by to get the next term? So when we look at 15 to 45, multiply by 3. Multiply by 3 to get 135. Then multiply 135 by 3 to get 405. So this would definitely be geometric, and the common ratio would be 3. Looking at the next term, to get to 6, we multiply by 2. To go from 6 to 9, we have to multiply by 1.5. Okay, so at that point, we already know, based on those two numbers, that this is not geometric. Right? Because those numbers are not the same, we are not going to have a geometric sequence. Alright, how do we go from 3 to negative 3? We multiply by negative 1. Negative 3 to positive 3, multiply by negative 1, multiply by negative 1. So is it a common ratio? Are we multiplying by the same number every time? And the answer is yes. And the ratio is negative 1. Okay. And the last example in this group, what do we have to multiply 1/2 by to get 1/4? 1/2, 1/2, and 1/2. Right, so is that a geometric sequence? The answer would be yes. And the common ratio would be 1/2. So in determining whether or not something is a geometric sequence, we're going to take and make sure that we're multiplying by the same number each time to get the next term in the sequence. Alright. Looking at example 2, they want you to find the recursive and explicit formulas for each of the following sequences. Alright. So we're going to start out by doing the recursive here. Alright, and then we'll do the explicit over here. Alright, so the first thing I want to do is I want to make sure that it's geometric, so I'm going to find the common ratio. Multiply by 2, multiply by 2, multiply by 2. So it is geometric. The starting value was 3. So then my formula is going to be a sub n equals a sub n minus 1 times 2. Okay, So we're just going to take the previous term and multiply by 2 to get the next term in the sequence. To get the explicit formula, it's a sub n is equal to a sub 1 times r to the n minus 1. So in this case, the starting value is 3, common ratio is 2, and then we leave the exponent as n minus 1. Alright, so those are those two formulas. Here we're multiplying by 1/2 to get the next term. Alright, so again we want recursive. And explicit. To get the recursive, the starting value was 100. To get the next value, or we do a sub n minus 1 times 1/2. Okay. On the explicit side, we have a sub n is equal to a sub 1 times r raised to the n minus 1. Starting value was 100 times 1/2 raised to the n minus 1. I'll put that in parentheses since it's a fraction. Okay, the next term, or the next example. All right, in example 3, 2 dealerships created sequences to show the depreciation of a Jeep Wrangler. What will be the price of the Jeep? What would be what will the price of the Jeep be after 8 years? All right. So we've got the two sequences here. We're going to start out by trying to find the common difference and determine whether or not it is geometric or whether or not it is arithmetic. Okay. So is there a number that we can multiply 25,000 by to get 20,000? And it's 0.8. Okay. Multiply that by 0.8. Multiply that by 0.8. Could have used 4/5 as well. I'm going to keep it as 0.8 right now. So we're going to use the formula a sub n is equal to a sub 1 times r to the n minus 1. Since I'm looking for the 8th year, I'm not going to go through and keep on multiplying by 0.8. I'm just going to do a sub 8 is equal to a sub 1 was 25,000. Common difference was 0.8. And it's raised to the 8 minus 1. Okay. And we get 0.8 raised to the 7th. So a sub 8 in this case would end up being $5,242.88. Okay, on the other side, we're looking for a number that we would multiply, but when we look at these numbers, in order to go from 25,000 to 22,000 and then to 19,000, there's not a number that we can multiply by. However, there is a number we could subtract. Okay? So we're subtracting 3,000 each time. Okay? In this particular case, this is not geometric. This is going to be what we call arithmetic. All right? Because we're adding or subtracting a specific number, it's arithmetic. All right, so the starting value is 25,000. In order to figure this out, I'm going to do a sub n is equal to negative 3,000 times n minus 1 plus 25,000. Okay, so then a sub n is equal to negative 3,000 times 8 minus 1, and this should have been a sub 8 plus 25,000. When I do the arithmetic there, I get a sub 8 is equal to 4,000. Alright. So looking at that, there's a quick lesson on geometric sequences.